Hello. In this video, we'll continue talking about conditionals with if-else, but we will be going more into Boolean logic. So we'll learn about Boolean variables, logical operators, and De Morgan's law, and then we'll put it together with if-else. The type Boolean is a logical type whose values are either true or false. And a logical test is actually a Boolean expression. We've already foreshadowed this in the previous conditionals video, but let's look at this in a little bit more depth. So, for example, you can actually save a Boolean variable. For example, Boolean can vote, and that's equal to age greater than 18. If you have a variable somewhere in your program that gives the age, this Boolean can now evaluate to either be true or false. Similarly, you can have a Boolean that uses some of those string methods that we've seen before. So you could have a Boolean is George and just check if a string called name contains the text George. And you can just have a Boolean which is just equal to true or false, and that's also a Boolean expression. We have talked previously about arithmetic operators like plus or times. Boolean operators also exist, logical operators, which include the exclamation point, which is logical not, a double ampersand, which is logical and a double pipe, which is logical or. So before, where we've had something like two ints, a and b, and we said a plus b, and that will evaluate to something, we can now write a and b. So each of these logical operands take Boolean operands and produce Boolean results. And I'll explain what each of these mean. So what do each of these operands mean? The and is where if you have two or more Booleans that are separated by this and, all of them have to be true for the entire thing to be true. So if I have condition 1 is true and condition 2 is true, then condition 1 and condition 2 will be true. An or requires only one of the conditions to be true for the whole thing to be true. So I could have condition 1 be false and condition 2 be true, and the whole thing would end up evaluating to true. And then finally, a not is a decision that only takes one condition. So if I had condition 1 was true and I put a not in front of it, then the whole thing would evaluate to false. Let's clarify further these logical operators using a truth table. So we've talked about the combinations of Boolean variables before. We could say a light bulb could either be on or off, which gives me two different combinations, basically on or off, but if I have two light bulbs, I can have four. We can also think about that in terms of true and false. So if I have the variable a and the variable b, they could both be false. A could be false and b could be true. A could be true and b could be false, or they could both be true. And now, if I want to evaluate and, I know that they both have to be true for the whole thing to be true. So it's going to work out that 3 of these are false, and only when they are both true is A and B true. Now, if I do A or B, I still have these same combinations that I had before for the variables, but now I have the fact that only one of them needs to be true for the whole thing to be true. So if both of them are false, then A or B will be false. However, the rest of the time, at least one of them is true, and so the whole thing is true. Now, finally, I have this unary operator, which is just with a single variable. So if I have A is true and A is false here, then I just flip it. So false becomes true and true becomes false. Okay, so these are the logical combinations that you can use in your code to make more complicated conditional statements. As I just said, you can use logical operators to form more complex expressions. But let's think about an example of what this would mean. Let's suppose that we have three integers, a, b, and c, and we want to get the minimum value of each of these. Now, you could do it with a nested if statement, or you could just check combinations to see which one of them are minimum. So let me show you. If B is greater than or equal to A and C is greater than or equal to A, then the minimum is A. If A is greater than or equal to B and C is greater than or equal to B, then the minimum value is B. And if A is greater than or equal to C and B is greater than or equal to C, then the minimum value will be C. Now, this may be a little bit easier depending on how you think about things than doing that nested if statement. De Morgan's law are rules used to negate Boolean tests. They're useful when you want the opposite of an existing test. Let me show you the two rules. If you have not and then in parentheses A and B, you can distribute kind of that not and turn it into not A or not B. Similarly, if you have not and then in parentheses A or B, you can make it not A and not B. So I always imagine it as distributing the not and then flipping the binary operator in the middle. Let's look at an example. If you had, for example, if x is equal to 7 and y is greater than 3, you can negate this whole thing and make it if x is not equal to 7 or y is not equal to 3. And so that may be in some cases easier to read than doing a not around the whole thing. Let's look at an example of short circuit evaluation. Let's suppose we have this expression which is if x is greater than or equal to 0 and math.square root of x is less than 15. Now, you might be concerned because you can't take the square root of a number that's less than 0, but luckily, you won't ever get to that second part of the evaluation if x is less than 0. That's because the first part of the conditional takes care of it. This is what's known as short circuiting. If you have two conditions separated by and, if the first condition is false, then the second condition is not evaluated because the whole thing is false anyway. And similarly, if condition 1 or condition 2, if condition 1 is true, then condition 2 doesn't get evaluated because the result is true anyway. So this could be useful in helping you decide what order to write your if statements and your conditional expressions in. Now, I do want to point out that there's a mistake you might make when using or. If you wanted to have a couple of different cases, like number is 1 or 2 or 3 or 4, and those are my two options, you might just end up wanting to do number equals 1 or 2 or 3 or 4. But you can't do it this way. This does not work because each condition is completely separate from each other. So you have to add the full condition. So you might see something instead like number equals 1 or number equals 2 or number equals 3 or number equals 4. So there might be some situations where you're going to get longer conditional chains, and you have to remember that each of those expressions need to be evaluated on their own. Let's expand a little bit on not decisions because this was the only one that's unary, so it's a little bit weird. It is the opposite of whatever the conditional statement says. And it's often used with Boolean variables. So if you had a Boolean variable that was called user verified, you might want to check that if the user is not verified and have it run some code that will allow the program to verify the user's account. Now, that's a cleaner way to handle a decision that requires a condition that needs to be false. Okay, I think we've gotten enough information about Boolean expressions and from the previous lecture what if else looked like. So I'll just leave you with a couple of practice questions. I recommend just pausing the slide and then maybe taking a screenshot or writing it down. There will be 3 questions. The first one I have here is what is the difference between these two code snippets? And you'll notice here that I have num is equal to 1, that looks the same. If num is less than 1, that looks the same. And then starting on line 5, I have else if num greater than 1, and here only num greater than 1. So take a moment to think and write a couple, maybe like 1 or 2 sentences explaining the difference. If there's a difference in output, if there's a difference in logic, something like that. Here are 2 more questions. When does the statement system.out.println x greater than 0 or x less than 0 print false? And then finally, rewrite the following expression, avoiding a comparison with false. So what that means is I want to get rid of this section of the code that says equals false. And remember, this evaluates if the whole thing is true. And let me just explain what character.isDigitCh means. So if the character that you put in here is anything of the numbers 0 through 9, then this whole thing will be true. But any other symbol, like maybe the letter A, or maybe like the symbol asterisk, something like that, those will be false. So take a moment to think about how you would get rid of that equals false and make this whole thing evaluate to true. And then finally, here's a sort of a De Morgan's law type of question. Which of the following is equivalent to the Boolean expression not, and then inside parentheses, I have 2 Boolean expressions, x greater than or equal to y, and then z not equals to x, and those are split up by an or, where x, y, and z are all meant to be ints. So take a moment to try out De Morgan's law and see what that gives you. And that is all I have for you today, so thank you for watching.